Good afternoon and welcome to this SMTA Europe webinar, which will be presented today by Keith Bryant. My name is Bob Willis and I'll be organising and running today's session. Before we start talking about our topic today and I introduce Keith to you, I'd first like to introduce you to the control panel, which you have on your screen at this moment in time. Now, the control panel allows you to do a number of things during the presentation. First of all, you can open and close the control panel by clicking on the orange button. This prevents it obscuring your view of the slides during the presentation. You can click on the blue button. This makes the image on your screen or on your projection facility go full screen, thus giving you the best view of the slides during the presentation. Now, if you have any questions during the webinar, please type them directly into the control panel, as indicated here by the red arrow. Now remember, if you're in a conference room by yourself or at your own PC, please type the questions while you think about it rather than perhaps waiting until the end of the session. We'll be answering as many of the questions as we possibly can at the end of the session this afternoon. Now, if you have any technical problems, use one of the telephone numbers provided on your registration and reminder emails. You'll also need your webinar ID access code, which was provided on your email. It's not possible for the presenter to assist you during live presentations. And just a reminder that as the internet is under considerable pressure, your area may have bandwidth issues, which may slow down the webinar content. So if you do have a real problem, then it's probably best to switch the system off and log in again. Just a recommendation. At the end of the presentation, we have a couple of survey questions on the webinar and its content. Please just take a couple of moments to give you feedback. We will be sending a copy of the presentation material to all of you this afternoon and those people that unfortunately haven't been able to attend. We'll also be making the video recording available through the SMTA website. But you, as you've registered, will get to see that recording and also receive the presentation material directly after we've put it together after the end of this session this afternoon. It's now my great pleasure to introduce our first speaker, in fact the main speaker for this afternoon, and I'd like to pass over the microphone and of course slide control directly to Keith. Good afternoon, Keith. If you'd like to take control of the slides and swing into action.
Right. Now we're all set up and running. Apologies for that. Right. This webinar is a taster session. The event itself is happening in early December over 2.5 days. Bob and I are good, but we're not good enough to give you full details of everything that's going to be happening at that time in the short time that we have with you today. So this is aimed to be a taster session to give you some good reasons to take to your boss or whoever you need to say that you need to come and attend the event in Amsterdam in December, or if you're a company that is into this kind of working in this kind of environment, that maybe you need to take a tabletop as well so that you can network better with the people who attend. So we've held this for a few years in Amsterdam now. It is an ideal location. Most of the major airlines fly to it, and it's a central hub for Europe for a lot of them. There's a mainline railway station underneath Schiphol Airport. So if you're in Europe and you want to travel by train, you just get the train to Schiphol, come out the top, and you're pretty close to where the event is. Amsterdam is also a major hub for all the road links within Europe for anyone who wants to drive, and anybody who's ever been to Amsterdam will agree with me that it is a wonderful place to visit and spend time. We are going back this year to the Park Plaza at Amsterdam Airport, part of the Global Radisson Hotel Group, recently refurbished, 4-star, very close to the airport. Even has a free airport shuttle bus, so you can travel to and from the event for free. So you just fly in, get the shuttle bus, and you're right on the doorstep. Also, very easy access to the city centre. Again, from traveling to Schiphol Airport and then getting one of the local trains, you can go pretty much anywhere that you want to if you're coming over for a couple of days before, after, or you just want to travel somewhere different in the evening. It really is a great event, great location. The Park Plaza also offers a discount which the SMTA have negotiated for hotel rooms. So like the normal, when you do these things, you just tell them that you're part of the group and you get the group rate. I'd like to start by going back to 2019, and if we can, the technology lets us, we're going to run a video which will show you at least to talk about of some of the highlights of last year's event.
I'm here with Rakesh from Specialty Coating Systems. They're also a table-topper at our event, and I'd like to get some feedback from him about how much he's enjoyed it and has it been of value for you to be here.
No, Keith, definitely it is one of the forums that we always look to come here. I think it provides us great value in terms of knowledge and what we present, and also we get customer leads who are really serious working with our conformal coatings. So it's always good to come here and learn, as well as provide information to participants.
Yeah, and I suppose your equipment fits very well within the harsh environment framework.
Yes, yes, and Parylene has been very well known for harsh environment. So overall, our business model fits with this kind of system. We always look for opportunities to provide protection of electronics, particularly in the harsh environment, and in general overall protection and for enhancement of reliability. So coming to this conference where a lot of industry experts are here, I think it's a great venue to interact and network, and SMTA definitely provides a great opportunity.
So if you had to choose one highlight of the event, what would it be?
Highlight of the event was to, as I learned from this, that many presenters really shared their perspective on the future electronics and what would be the requirement in terms of the testing, how the materials can really support for their advancement.
So this is going to help you guys with feedback to your research and development team.
Yes, yes. So it's a research and development team as well as for the marketing and our overall business, that what are the areas that really we need to focus and do the testing so that we could offer our services to that particular product or industry.
Well, it's really good to hear that you think this event is of value, and we'll put you down on the list for next year, Rakesh.
Yes,
thank you very much for your time.
Keith. Thank you for inviting.
Hi, I'm here with Mike Bixeman, and Mike is the ultimate controller for the technical content of this event. So I guess my first question is, are you happy with how the technical stuff is going so far?
Absolutely. I think one of the strengths of the program this year has been the technical content. We've had a wide breadth of presentations on a number of key topics that relate to harsh environments. So yes, I think the technical content turned out quite well.
Yeah, I have to say one of the things that people have been complimenting you on is the really good mix of academia and, let's say, industry expertise.
Yes, and not only that, a lot of the different areas were quite good as far as understanding and learning about some of these technologies. So I thought it turned out well.
Yeah, I have to say you've brought a lot of knowledge to the delegates, and the feedback has been really good. So
that's good. That's good. Well, as good as the content has gotten over the past 3 years that we've done this, hopefully that will bring in more people to the conference. Our attendance has been good, but it would be great if we could continue to see it grow.
Yeah, numbers are up on last year, and they were up on the year before last year, so we're moving in the right direction. But I always agree with you. There's always room for some more people sitting down and listening.
Yes, that's true. So.
Okay, and I understand the plan at the moment is we'll be doing a similar event around the same time next year.
As far as I understand it, that is true.
Hi, Hi, I'm here with Dave Hillman from Collins Aerospace, who has been the keynote speaker of the Harsh Environment Conference for SMTA Europe, and also did a personal development course, it was called, wasn't it? Yeah. In the old days, we'd call it a tutorial, but now it has.
Yeah, it's going to be called something different.
Now it has to have a posh name. So yeah, the audience have really loved you. Have you enjoyed being here?
I love coming to SMTA events. The organization of this one, the technical papers, the breadth that it covers. We've gone from high-end technical parts to cleaning processes. So yeah, this is the place to be to get good technical information.
Yeah, I have to say, everybody that I've spoken to has been really pleased with the quality of the presentations and, the depth. We've got more people here from universities and that kind of thing than I've seen for a long time.
And I think that's one of the balance. It's not just academia or industry, but it's a very big collision of those two things on a lot of common topics. So I think that's a big plus. We don't see it in all the conferences we go to. Here we've got it really high quality.
Yeah, and I have to say, we're all pleased that you guys, so by these guys I mean he's here with his partner in crime, Doug Pauls, and they've been definitely the highlight of the gig. So I want to say a personal thank you to you both for coming over.
Our privilege. We've wanted to come in person, and this year we got approval to come, and it's just been everything we thought it'd be and then more. Just a lot of fun to be around all and do this technical exchange.
Well, let's hope we see you back here next year.
That's our plan.
Hi, this is Keith, and I'm here with Beth from Electrolube. Electrolube are here as table toppers and also obviously attending the event. And I believe this is your first time here, Beth.
Yes, this is my first time here, SMTA Europe, so it's great to come along.
And I suppose the first obvious question is, have you enjoyed it?
Yeah, definitely. I've really enjoyed it. It's been great to listen to all these presentations about what's new, learn a lot more, particularly about automotive electronics, what's going on there. And it's great to get around and talk to people and try and help provide solutions where we can.
Okay. So give us one or two highlights.
So definitely sort of getting to network and meet all these different people. So that's really important for the industry because it's really interesting for me because everybody seems so willing to help and provide their knowledge and support from their experiences throughout the industry. So that's definitely been a highlight for me. And the presentations have all been great. So I've taken something away from all of them. So
not one highlight, but just the event is a highlight.
Exactly.
Yeah, and from a tabletop perspective, have you got to interact and sort of a little bit commercially? It was obviously, at the end of the day, you have to convince your bosses it was a worthwhile thing. So from a commercial point of view, do you think it's been good as well?
Yeah, definitely. I mean, throughout all the breaks, people are getting a chance to walk around and speak to everybody with a tabletop. And it's a great opportunity to meet people.
So, this year's conference. Best practice for building reliable devices to perform in the what we consider to be harsh environments. We've got some specialist stuff this year on bottom terminated components, power electronics, assembly challenges, cleaning, coding, process controls, origins of some ionic contaminations in automotive electronics, and a lot of stuff in challenging areas, high temperature soldering, low temperature soldering, and even some work on the new standards. So we have definitely a lot going on over the 2.5 days. I sometimes get asked, Keith, what's a harsh environment? Obviously, we've got under hood stuff in automotive. We've got the things that go down oil wells, but with harsh environments these days, there are a lot of different areas where you would consider the environment to be harsh for one reason or another. Even now we're seeing some consumer stuff where the boards are being subject to some quite nasty environments inside dishwashers and washing machines. So, harsh environments are really just about everywhere. So, we've got a professional development course, the same as last year, and we've split the presentations up into 4 different sessions so that we've got a focus in each one of the sessions. At any event like this, there are networking opportunities. We deliberately promote these by having a welcome reception at the end of the first day, where we feature local Dutch beers, soft drinks, and also local delicacies of nibbles, which I have to say the Dutch do this very well. In addition to this, we have a good tabletop exhibition, which is very close to the event itself. So it's not in a different hall. It's not a walk away. It's very close. This allows everybody to network with the exhibitors, chat with people, and build really good relationships. This year's development course is Advanced Materials Analysis for Reliability in Harsh Environments. It's very interesting. It's an exciting approach to reliability testing. It's faster, it's more accurate than traditional systems have been, and it's a course that's well worth attending, and I'm planning to be there myself. So, session topics for 2020. Electrochemical reliability of PCBs in the automotive industry. Obviously, this is always a strong topic. Automotive reliability is always a huge thing. Those of us who work in the industry for a while know that this is something that's not new. It's always been with us, but the demands of the automotive industry become higher and higher. And now, of course, we've got autonomous vehicles, we've got electric vehicles, we've got hybrids, we've got a lot of other things as well. Leadless components, the QFNs, and all the other lovely things that we have to work with, and bottom terminated components have their own unique reliability challenges, and we have a session which is going to look at those in depth. We're also looking at modeling and failure mechanisms in reliability, some predictive work also to see if there's a correlation between what we think is going to happen and what happens in reality. And then the other one, of course, involved in high reliability and harsh environment stuff. There's always a huge amount of testing. A lot of this is done now in climatic chambers. The HAS tests and all the others are becoming harsher and harsher, and it's always a continuous goal of all the people in the industry to improve the reliability of these systems. So, some of the presentation highlights. Measurement of ionic contamination to try and predict reliability. Looking at the IPCJ standard 001 in automotive, and if you're looking for an automotive presentation, Robert Bosch is one of the best companies to be listening to, and I have to say Lothar is one of the best presenters. Then we move from things that travel fast on land to space applications, and we look at reliability of microvia technology in these applications, and this paper is from IMEC, again another huge organization in the reliability area. University of Hanover are presenting advances in packaging for future technology trends. Again, you know, the title does what it says on the tin. I'm sure it will be something which is up to the minute and state of the art and of interest to everybody who listens. This last one is something which is becoming more and more prevalent in harsh environment and also in high reliability automotive areas. Reflow residues which get trapped under the bottom terminated components or the QFN type things, residue is hard to cure in these areas, so a lot of the residues are a little bit active and not benign, which can cause some problems. And if you add humidity there, and you add an electrical bias as well, you've got a you've got a real potential for having some very interesting problems appear, and the University of Denmark are presenting on this. I'm now going to hand over to Bob, who's going to talk in a little bit more detail about some of the presentations that are happening.
Well, thank you very much, Keith, for the overview. I just want to talk about a couple of the presentations which will be featured in the session. Of course, the content may change over the time between now and the end of the year, but who knows? Now, it does seem strange to be talking about low temperature materials in a harsh environment conference, but I was asked to give a presentation on some of the work that I've been doing, and of course some of the work that's already been done within the industry. And certainly in my own specific case, I've had failures of a low temperature alloy in a demanding environment, but I've also used a low temperature material to solve a problem in a product that in a more demanding environment, perhaps not harsh, high reliability, but certainly in a more demanding environment. So again, you know, sometimes there are fitness for purpose issues, and it's getting the testing right. The thing I'd like to highlight is this is a graph that is included in the INEMI project roadmap, and they've been doing a couple of projects on low temperature material for the last couple of years. And one of the things we certainly see within the industry is low temperature materials increasing in usage and popularity. And certainly the first time I was involved in low temperature, which was when we went to Japan with a smart group and discussing the use of low temperature materials as an option to sack alloys. And of course, people highlighted the well-known facts that the material tends to be more brittle, so for certain applications it's not ideal. From a printing, from a reflow technology point of view, I don't see too many challenges there. But what I think is there's a lot of companies that are perhaps not looking at the perhaps more mundane side, the hand soldering, the rework, the removal of components from printed circuit boards. So you've got to look at that as well. It's not just the sexy reflow stuff that everybody tends to concentrate on. So we see a growth in it, and we'll be looking at some of that and some of the results. You know, much of the work on low temperature materials was originally done by Hewlett-Packard, and they've had many products in the field. More recently, Alpha and Indium have promoted the use of low temperature materials, as has other materials within the supply chain. More recently, IBM, Lenovo have produced laptop boards and been using that technology, I believe, for around 3 years now. So it's interesting that they've got obviously a wealth of experience on the materials that they're using for those type of applications. In the past, what we've seen really is the use of low temperature materials for the repair and rework of area array packages. And the reason there is to make a reliable solder joint as a repair on a product and minimizing the possibility of damage to other adjacent components. Because if you're replacing a part, you want to eliminate the possibility of secondary reflow, which can occur, and I know from my own experience it does occur. And Indium have been great exponents in promoting that technology in terms of rework and repair, with excellent presentations from Ning Chang Lee in the past. So in terms of our process, we're looking at processes below 200 degrees C in terms of soldering potential. But still, we've got to think about the support of thin boards, flexible circuits, etc., because those are still issues that we need to consider and deal with. In terms of profiles, just to give you an idea, I'm just showing you a couple of examples here of profiles and profile temperatures against SAC, which is the baseline of what most products tend to be compared to. And more interestingly, you see their joint reinforcement paste. These are pastes that have got a built-in epoxy material within their flux composite material within the paste. And it's interesting, those materials and how they work. I've only been able to actually get one sample of one product, and it took me quite a long time to get that. But it's interesting on the type of results that you can get with that as an alternative. 2 years ago, I did some work on rework and repair, just for my own experience, as part of the rework experience that we ran with Smart Group at that time at 2 exhibition stands. And basically what we looked at, the removal and rework of BGA products, and then obviously we did X-ray afterwards. We did shear testing, etc., and found those were potentially very reliable solder joints for a rework application. More recently, I've been doing some work with a good friend of mine, Richard Boyle at Henkel, and basically what we've done is produce some test boards with QFNs, and they're currently doing temperature cycling. So we'll look at those results when we get together later on in the year. Now, a couple of other presentations that are coming as part of the conference program. There are 2 presentations being given by my good friends at NPL, and one of those is a new test method, and they're documenting a procedure which hopefully will be submitted as a procedure for testing, and this is condensation testing. Probably a few of you have been aware of failures that you may have seen during traditional SIR testing, surface installation testing, or failures actually in the field due to condensation. And the existing condensation test methods have not been ideal to really give us a true repeatable test. So what one of the engineers at NPL put together is a condensation test which controlled the amount of condensation that is actually coming onto the surface of the printed circuit board and onto components. And by controlling the temperature of the printed circuit board assembly and the environment, they were able to differentiate the amount of condensation that actually takes place. This photograph on the bottom left just shows an example of one of the platens with test boards in place, and the typical signature in terms of measurement you would see over time. So it's the sample temperature and the actual board and the relationship to it. And as you can see, it's quite controlled in the amount of change that's taking place. This is an inside view, so basically a camera mounted inside the test chamber looking at the surface of printed circuit boards and the amount of condensation. And the interesting thing that will be presented during the conference, the SMTA conference, is the control of the amount, but also how components and different types of components have an impact on the amount of moisture condensing on the surface. So something there that came out of this research work that will be presented by Martin Wickham. In addition to that presentation, Martin will also be looking at obviously traditional failure modes due to condensation, contamination, and higher voltages when we look at the use of higher voltages in car systems for the future, and particularly testing for CAF at 1,000 volts. So that's an interesting issue to be considered. Now, many of you will probably know that CAF failure or CAF generation is an internal board failure mode where there is separation of the glass bundles, and that gives a pipeline, if you like, to any residues that then can form conductive paths or certainly produce a low resistance path to an adjacent termination. So Martin will be looking at the testing and the results of that testing that they've seen so far. The end goal with condensation and also this high voltage testing is again to put something in the public domain, which is a specification or a test method which will actually improve on things that we've seen in the past. If you are interested in this particular subject, Certainly Martin will be providing or giving you access to some of the reports that have actually been produced over the last few years by NPL on the CAF formation and the actual failure mode of CAF within a printed circuit board. Now, the condensation test I've mentioned, and I've had a little bit of experience of using this test with my good friends at NPL, and what I've been doing is doing some testing on board assemblies, and I'll report this. So basically with SIR testing, we're looking at a standard board which is well known in the industry, and what I did is took this printed circuit board and added test patterns to it. I did in fact submit this to Doug Pauls, who was the chairman of the committees involved in SIR and the SIR handbook, and basically what I did was add QFNs, and I added a test site which had parallel tracks, so it's a comb pattern similar to you'll see on any other test board, but we put it between the terminations on QFNs. We were only could add in 2 test circuits because of the other tests that were going on the printed circuit board. So you've basically got the result for 2 of the QFNs and then the result for another 2 of QFNs, as opposed to having 4 individual test results from this test. And we did standard SIR and also condensation testing on this after building the product on a production line that we were running in Sweden. So this is the final assembly. You can see the QFNs on there, and we've got all the data on the paste that we use, thicknesses, etc. So again, that all can be exchanged. And you'll notice that also we've got selective soldering locations on this particular printed circuit board. For those of you not familiar with the pattern, you can see the other areas of SIR points of measurement highlighted here, and again documented on the side. But for those of you who are familiar with this test pattern, then it will be quite obvious to you, apart from the addition of the QFN packages. So this test board, first of all, whenever you're doing any testing, you'll have a bare board, a board which is your reference board. So what you're looking at here is the resistance measurements when introducing to a climatic testing. The criteria is that anything below 8 would be a failure. Anything above 8 is perfectly acceptable. But please, one word of warning, if you're ever using SIR testing, always look at the samples. And quite often I've worked with companies that look at the data but don't look at the samples. So you can have a pass and you can have a failure, but it's looking at where they fail. That's the most important thing. So if you're ever doing testing with a laboratory, make sure you look at the sample parts as well as the data together. For those of you who are familiar with this test, you'll know that that's obvious, but please look at 2 sides, because those 2 sides tell sometimes a slightly different story. So here's an example of one of the result boards, and it's amazing that it's number 13, which is the board, unlucky for some, as they say. But you can see the test results that I've shown here. Everything is above 10, whereas 1 point is just below 10, but we've got a very erratic reading. So something is happening there, which will then potentially lead to corrosion and possibly dendrite formation. And we've got all the results that will be displayed basically at the conference. This is just a close-up method, a close-up of the packages on the surface of the printed circuit board. The other technique that I use to look at these is what I call back grinding. So rather than ripping the component off the board, I like to back grind. So it's grinding through the board to look at the back of the device and expose the pads. And then if there is any corrosion products, if there is any residue, if there is any dendrite formation, it's visible straight away from the back view. So I find this a very useful technique, and I've used it for many years. Of course, you can use X-ray. An X-ray will pick up dendrites, I pretty much guarantee it. You have to take a little bit of time to find them, possibly, but if you look at the data, that will indicate where they actually are on the board. But a close-up view like this through the board with backlighting is surprisingly good at showing where corrosion has taken place. So basically, setup and criteria of your traditional SIR is highlighted here, and this is obviously documented in the IPC standard. Now, this is just one other example of test results from SIR, and this is on a reference board, and you can see the typical results. And here we see a real mess, and again, this is our QFNs playing up. But interestingly enough, the corrosion or the dendrite formation was only around the outside termination, so not actually underneath the body of the device. And one of the potential reasons for that is that if you've got a flux which has got a fair amount of residues in low residues, in low residue criteria, if you like, because obviously it's a lot less than traditional base, that tends to block some of the material, i.e. the moisture condensing on the surface. So it's actually creating a barrier. Just like in the old days of hand soldering with rosin fluxes, rosin used to protect the surface of the board, and we took it away when we went to no clean, no protection. Having something there does give a level of protection, certainly underneath some of the packages. Again, just my own photograph of the photograph you previously saw, but here it's loaded, and these are my test boards in the condensation test system that's actually going through the testing at NPL. And just to prove that there's moisture on the board, here's my finger on the board, and just to show the condensation, I wasn't sitting inside the chamber, I hasten to add. I did open the door to make the video, but you can see the point. It is fairly consistent coverage over most of the devices. As I said, Martin will explain the nuance of different devices and the effect during his presentation. So this is just a couple of more results, but it's showing slightly different squiggly line, as I tend to refer to it, the actual test pattern results on the condensation testing. So we have to sort of change what we're actually looking at, but we're still looking for that magical number at this moment in time. Anything above or anything below 8 would be the criteria to look for. Now, one of the nice things about the condensation testing is that it gives us the ability to test much quicker. So rather than a 21-day test or whatever test you want to perform, we're looking at a test which actually can be conducted much more quickly. So that obviously has an impact on cost and obviously proving a product out much more quickly in manufacture. Now, these are some of the failures that on some of my test boards, because most of the test results that Martin will talk about are owned by the companies that did the project, but this is something I did with the guys, and it's in the public domain, but it shows the types of condensation failure that we saw that we can trace back to the curves. Now, because Doug Pauls was heavily involved in this project, he was interested to play himself. Doug is like that. So basically, I sent him some of the boards, and he did his own testing, just to prove out or disprove or tell me how badly I'd done on the design of the test board. So we'll be showing some of the data that Doug produced and provided for us using traditional SIR testing on some of the samples, which is fairly unique. And also he tested some of the boards for contamination using DI fluid, so isopropyl alcohol and isopropyl and DI water, and did chromatography testing, and these are some of the results that we've got. And I put the criteria, so when you get a copy of the slides, you can relate the criteria in the IPC standards to the results that we've got. I'm not saying these are perfect, but these are just shows you the whole of the process that we've gone through on this type of evaluation. Okay, so that's a quick overview of 4 of the papers in the session. It's now again my great pleasure to hand back to the man at the other end of the world, the other end of the UK at the moment, Keith Bryant. Hopefully you're there, and you're there and raring to go, Keith.
Thanks very much, Bob. I think that was a great overview of 4 of the interesting presentations. I'm now going to cover the presentation that I'm going to be giving myself, which is examination of failure mechanisms in IGBTs. IGBTs have been with us for a while now. They're becoming more and more complex. They're becoming, in some cases, bigger and heavier. And you can find them all everywhere now, from wind farms to rice cookers. So really common technology. It varies a lot. And on the left, you have a good one. And on the right, you have a not so good one. I did actually label them new unit and failed unit, but in reality, I don't really think I needed to do that. This failed unit came out of a wind farm that was offshore by quite a long way. And as you can imagine, it was a very expensive, what was described to me as a catastrophic failure. These these IGBTs have a real mix of materials. You have a copper base plate. Some of these base plates now are up to 13, 14 millimeters thick because this thing generates a lot of heat. You then have a solder layer connected to copper. You have then a ceramic, you have more copper, you have more solder, and then you have a chip on the top with aluminium bond wires normally now, or possibly copper bond wires. So you have a real stack of different materials. You have 2 solder junctions and you have 2 adhesive junctions also. So you have a mix of joint materials, you have a mix of materials with different thermal coefficients of expansion, and you have a huge lump of copper sitting on the bottom. Voids, we all know, are problems in a lot of areas. People worry about voiding weakening joints. With IGBTs, the voiding is actually a different worry. If you look at the nice little lines of the 2 rows of red arrows on the left, you can see the heat is coming out of the circuitry, through the die attach, through the ceramic, through the solder, into the heat sink, and out into the world. The 2 on the right are slightly different, because if you have a void in that solder layer, air is really bad at transferring heat. Ceramic, copper, all of these things transfer heat very well. But the problem is, if you have a void in that solder, instead of the heat dissipating, the heat is fed back into the die. The die is already heating up. If you can imagine that as a circle instead of 2 lines, it very quickly becomes a vicious circle. And what happens at the end? You overheat the die, the die is probably going to crack. If the die cracks, then the system is probably going to go into catastrophic meltdown, and you're going to end up with something that looks like that on the right-hand side. These are heat graphs showing differences in heating across the die at different times. You can see very, very quickly the die is heating up, and you have a lot of varying hotspots, which are really potential sources for problems. Obviously, if you have voids in your system, this is the sort of thing that you're going to see. What we look at here through the rest of the presentation is using X-ray to see these faults, also using scanning acoustic microscopy and some other things to look at the failures and to see if there's a way that we can improve them in terms of manufacturing standards and manufacturability to make sure that we don't have these failures. The IGBT units themselves are quite expensive, but that cost pales into insignificance for the cost of fixing some of these things that are on offshore wind farms or wind farms in remote locations. And obviously, if these are on electric vehicles and they fail, you have a whole potential series of other problems. So IGBTs and failure mechanisms are quite a hot topic, and hopefully we will cover them well beginning of December. So let me try and give you a few more things to convince you. Obviously, it's a good networking event. There's plenty of free time to mix with the speakers, the exhibitors, and also a chance to chat with the other attendees, a good opportunity to build up your network of contacts. Obviously, also, there will be people there from the SMTA and the SMTA Europe committees who will be happy to tell you more about other events that are happening and other ways of getting involved and how you can see a lot of added value from SMTA or SMTA Europe membership. And these kind of events always bring value to you, and they also bring value to your company. So I thoroughly recommend that if you're able to, you come along and join us. And as I say, if you're a company involved in this environment, then it's well worth taking a tabletop so that you can promote your technologies to the attendees and also obviously the speakers. So I'd like to thank Bob very much for his excellent work, and thank you all for your attention. We've had a very full house today from all around the world. So I'll pause now and throw everything over to Bob, so we'll find a way of taking any of your questions.
Well, thanks, Keith. I really appreciate that. I love the use of IR cameras. I just wish that I'd had one myself, back in the day, and certainly probably wish I actually had one myself now for some of the work. But it's one of the things I always ask if I'm going into a facility, let's say to do some work on robotics, robotic soldering and stuff. I always go in the maintenance department first before I talk to the engineers. Said, have you got an IR camera I can borrow? And it's amazing. They quite often have them, and they just use them for traditional testing of sort of loss of heat and overheating of wires in certain. I know they're not the same accuracy as the ones you were using, Keith, but yeah, they really are a useful tool. Okay, so a reminder, if you've got any questions, then please just type your question directly into the control panel, and both Keith and myself will do our best to answer those questions. So type them directly into the control panel, and we'll do our best to answer them for you. I just thought it was interesting that, and Keith may have a view on this, it's just interesting that the spread of people that are attending this particular webinar, heavily biased the USA, and I guess, obviously from the SMTA heritage, starting off in the US at the same week, sorry, not the same week, the same year as our other organisation, who Keith and I have worked with for many years, started off. But Europe's growing. That's good for webinars, isn't it, Keith?
Yeah, it certainly is. We have almost a third of the people out of Europe, 10% out of the rest of the world, but as you say, the majority from the USA. So I hope they're going to be able to make the trip, because I know one or two of the major US airlines use Amsterdam as a hub, and we had a good level of attendees and also actually speakers previously from the US. So guys, if you want to come to Amsterdam in December, I can promise you it's well worth the trip.
Yeah, and certainly if you talk to the guys at Rockwell Collins, I think they've only had to do their presentations once online. They always want to attend.
Yeah, they certainly do, and I'm sure they'll be trying hard to get there this year as well.
Okay, so just a reminder, before we take questions, please, if you've got a question about anything we've talked about, then please just type the question directly into the control panel. But while you're still thinking about that, just as a couple of examples, if you want books on extreme environments or high temperature electronics, these are 5 titles that I'm aware of when I first started looking at these technologies. So these are all available. There is 3 more that's recently just become available, and one particularly on extreme environments. And there's a lot covered in there on sort of space applications, but also on die attach materials. Now, Keith was involved with a soldering company in these particular materials a few years back. So that's obviously an interesting topic to him as well. And more recently, this online title, Harsh Environmental Electronics, is also available. If you do a search for any of these titles, some of the older books will be available probably in second hand, so you'll be able to pick them up quite cheaply. The only word of warning, and I've said this to every publisher when I've done book reviews, is that they do not cover the soldering of printed circuit boards, whether they be metal boards, polyimide boards, whatever the base substrate might have to be for a traditional substrate as opposed to silicon substrates. They don't really cover that very well, which to me is a missing link. So if anybody wants to write a chapter or something, then you should get involved with some of these publishers. So let's pick up on the first question. So let me pick a question straight away. There's somebody asking, is the condensation plate, the NPL condensation system, available commercially? To my knowledge, Karen, that it's not. However, I'll pass that question directly to the guys at NPL to come back to you directly. So to my knowledge, no, but I'll let them answer the question because they may be more up to date than me. Mike just asks, and Keith, you can tell him, what are the dates in December again?
Oh, I was trying to remember that myself, Bob. Bear with me for just.
Okay, I'll fill in with another question while you're waffling. Okay,
yeah, go on.
Question to Bob. One slide showed the limit of ionic content performed by IC. Would those numbers are criteria for ionic control? What I would say is that the basic criteria, I don't think it's been reviewed. It was put in place for ion chromatography a few years ago when that standard was produced. Now, whether it's actually changed or it needs to change, I really have only used ion chromatography on one kind of sort of evaluation. So I wouldn't really be the best person to answer, but I will ask that question of Doug, and perhaps he'll be able to answer that specifically. We used to have an ion chromatography system specifically at NPL, but you really need to be running the system all the time to actually get the value out of it, and obviously control and calibration and stuff like that. And at that time, certainly in the UK, there wasn't that much call for ion chromatography testing. Now, today, it may be a completely different story. Keith, you got the dates?
Yes, Bob. 1st to the 3rd of December. My apologies. I thought that was it. And there are sometimes when you get asked a question, your mind goes blank or you start questioning yourself. So I did want to do a double take. But yeah, it's the 1st until the 3rd of December.
And Amit asked the question, any sessions on MEMS at the harsh environment? I don't really think that we cover, but MEMS as a topic has been covered by SMTA in the past, hasn't it, Keith?
Yes, it has been covered. I don't think there's anything specific, but what I can tell you is the agenda and everything else is already up on the SMTA Europe website. So if you want to have a full look at all the papers and see what's there, then anybody who wants to just needs to put SMTA Europe in their browser, click on events, scan down to 1st to the 3rd of December, and you will open the Harsh Environment Conference. There's a PDF there which shows all the presentation titles and all the presenters.
Okay, next question. This is a question about the SIR results with condensation. This is Alexander. hopefully I pronounced that correctly, any acceleration factor known for this test? To be perfectly honest, that's a little bit above my pay grade in terms of my knowledge, so I can't answer that question. Keith will probably clap in a moment that I haven't been able to answer a couple of questions today. But again, I'll address that to Martin. So I apologise that I can't answer that particular question. Previous question to that relates to that, and it's about criteria for SIR. I would totally agree with you that you should be able to get surface insulation resistance testing results for traditional SIR, well above 10 times 10 to the 8th. And yes, anything that dips down below that, but even recovers, to my knowledge in the standards, is acceptable. However, I go back to the point that I made. You look at the results and then you look at the samples, because yes, you can still have a failure and it can recover, but I think it's so important when you're doing any environmental testing or mechanical testing to look at the failed bits. A lot of people used to do shear testing of solder joints or push testing or pull testing, and they looked at the numbers. Now, the numbers is good data. You put it in a graph and it's good data, but look at the failure modes. Where did it fail? That's just as important as the numbers. That's just a personal opinion. A reminder, if you've got any more questions, just type them directly into the control panel, and Keith and I will do our level best to answer them. I think that one of the great events at our conference is the workshop, because the experience there on failure analysis in general terms is exceptional.
Yeah, I would completely agree with that, Bob.
Yeah, so I'm looking forward to that failure mode specifically on this type of application. So we got no more questions coming in. Any last comments that you would like to make, Keith?
Yes, I'd like to thank everybody for listening. We had pretty much a full house of attendees, which is always good to have. Hopefully I'll see some of you, or hopefully most of you, in December. And I'd just like to say, please take care and stay safe in these difficult times, whatever country you're in. We're all suffering a little bit at the moment of working from home and not being able to do a lot of the things that we want to do. But I'm sure, like me, everybody else realizes that it's important to stick to the rules and behave, because the sooner that we get this thing under control, the sooner we get at least part of our lives back. So I just like to thank everybody for listening. Thank Bob very much for his hard work and support, and just ask everybody please to take care and stay safe, and hopefully see you in December.
Thanks, Keith. So just a couple of other things. Thank you very much for Karen. I will correct the spelling mistake on residues, and I appreciate that you also have a problem with spelling that particular word. But as you're doing it in a second language, you're excused more than me. Also, just a reminder that you will be sent a copy of these slides literally after we finish the webinar, and Keith and I have sorted those out. And the recording will also be available for you as well, either directly via email, or it will be available from the SMTA website probably in a couple of days, but you'll get the link hopefully sooner than that. I apologize to any of your colleagues that couldn't join us this afternoon because literally we were, although this is free, this event, it was sold out quite considerably. So thanks for attending, thanks for bearing with us, and it's a pleasure, as always, to work with my good friend, KB.
Thank you, Bob, and thank you, everybody.